on time. It's a very good habit. What is very important down the line for all of you is quickly joining the sessions on time and matching up with others' speed as well. That's a very tough thing, actually. You'll so slowly realize that catching up with somebody else's speed is a tough task. Doing the job all by yourself is a much easier task than making others do the job. Oh, that's what exactly is the managerial job. Someone asked me why managers are actually paid more than people who are really working, or exactly if someone can put why certain jobs are highly paid and why the other one is not much, though few might involve more physical strain. What could be the answer? Why managerial jobs are more paid than a normal job? And the answer is very tough, actually. Why? It's because doing the job all by yourself is a much easier task than making others do the job for you. And managing, people management is the toughest it is supposed to be. So is the discussion. Somehow, I think taking an extra class is a double-edged knife job. Why? I feel very little more leisure. I feel I can speak little more information apart from your regular academics, which I know many might like or many may not like. Then, if by chance you all are bored, next time if I ask for your presence for an extra class, the class would be empty. Now it's much more difficult bringing you all online, okay? Or might be easier because you'll just log in and you'll take a nap. It could be anything. So things have become very different. Okay, then we'll do a quick brief recapitulation of what all we have discussed in the yesterday's class and just go ahead with it. Now, for all those who have joined, just this is what exactly I wanted to tell you. See, many teachers, chemistry teachers, like in our college, my colleagues, who are very efficient, they explain the subject so lucidly, very wisely, and they actually absolutely, the time given to them is sufficient to deal the subject and also do a good amount of revision. Okay, that's the efficacy. But okay, I'm a little slow, but then I request for the extra hour, which many a times students do oblige with it. Now, this is what exactly I want to address with your learning skills as well. The class will be, of course, heterogeneous, okay? And you might understand this topic very quickly. And they are very efficient. It's really good about it, great about them. But there are few who are a little slow. But then you should never lose the spirit of learning any subject. Actually, chemistry is a much easier one because all these things you have studied in your intermediate. But there are new subjects like your PPS or your BEE and all, which are your part of your core subjects. Okay, then you need to develop that patience and that skill of learning new things efficiently. What you need to do is always stick to the basics. Once you crack the basics, rest all are very easy. Okay, that means what? If you take time learning the basics also, no problem. But once you learn the basics, the main subject would be more and more interesting to you and you'll learn it much faster. Okay, తెలుగు రెండు ఉంటాయి, ఆలస్యం అమృతం విషం, అంటే లేట్గా చేస్తే ఏదైనా ఇదవుతుంది అని చెప్తుంది. అదే నిదానమే ప్రధానం అంటారు. అదేమిటి రెండు కాంట్రాస్టింగ్ స్టేట్మెంట్స్ ఒకటేసారి వేస్తారేమిటి అని అంటే, ఎలా అంటే కొత్త సబ్జెక్ట్ నేర్చుకోవడం ఆబ్వియస్లీ టఫ్, కాబట్టి కొంచెం స్లో నేర్చుకున్నా, పర్టికులర్లీ పీపీఎస్ ఆల్గోరిథమ్స్ రాయడం కానీ అవి కానీ, లేకపోతే బీడబ్ల్యూ మీ కోర్ సబ్జెక్ట్ కానీ స్లోగానే నేర్చుకోండి, హడావిడి ఏమీ లేదు. బట్ కాన్సెప్ట్ నేర్చుకున్న తర్వాత యు ఆర్ నెవర్ స్లో, చాలా ఫాస్ట్గా మొత్తం సబ్జెక్ట్ని కోపప్ చేస్తారు. దట్స్ ద ఐడియా. ఓకే, సో ఇట్ మీన్స్ వాట్, నేను కూడా probably I might have started little slow, but then I'd like to finish off the syllabus at the earliest. That's what even I would like to say. Okay, now it's 11:10. I'd just start the class. And good morning once again. And yesterday we have concluded our discussion with the numericals of the Nernst equation. Okay. Now, roll number 71. Good morning.
Good morning, ma'am.
Are you there?
Yes, ma'am.
Yeah. Now tell me what it means by Nernst equation, or when I had used this Nernst equation. When the Nernst equation is used?
In non-standard conditions, ma'am.
Non-standard, non-equilibrium conditions. అంటే ఇప్పుడు నువ్వు నాకు చెప్పాలి స్టాండర్డ్ కండిషన్స్ ఏంటి.
If the temperature is at 25 degrees Celsius and the concentration is at 1 molar, that is standard, ma'am.
Standard condition. If the particular temperature, generally we don't bother because usually we'll maintain 25 degrees centigrade temperature is always maintained, plus or minus. But we'll more focus on the concentration of the electrolyte. If the concentration of electrolyte is not 1m, then the conditions are non-standard. Correct, Dishi? So Nernst equation enti? Can you tell me the formula of the Nernst equation, how it is mathematically represented?
E cell is equal to E naught cell minus 0.0591 by N into log products by reactants. Concentration of products by concentration of reactants.
Okay. Dikshita, good. Okay. You have talked about the concentration of products and reactants. Okay. Sare? So, what is your statement? While applying Nernst equation, does the stoichiometry of the reaction is important or unimportant?
Important, ma'am.
Important. Why? The concentrations are always raised to the powers of the stoichiometry. Correct?
Yes, ma'am.
Okay. Now, good. Good, Dikshita. Next, roll number 72.
Yes, ma'am.
Good morning.
Good morning, ma'am.
Okay. Sumit.
Yes, ma'am.
At which electrode Nernst equation can be applied? That means at anode, cathode, or both the electrodes, or what it could be?
On both electrodes, ma'am.
Any electrode?
Both electrodes.
Both the electrodes.
Yes,
Or
ma'am.
only can it be applied to anode?
Yes,
Alone?
ma'am. We can only on cathode or anode.
Sare. Okay. Sumit, ఇప్పుడు చెప్పు. If I'm considering oxidation reaction takes place at which electrode?
Anode.
Anode. Sare. In such cases, if I keep cathode as inert reference electrode, ante it is under standard conditions. So, and I'm applying Nernst equation at anode. How the Nernst equation would be mathematically represented? Cheppana idi?
Yes, ma'am.
Cheppu
E
emotundo?
anode is equals to E naught anode minus 0.0591 by N log M power N plus concentration.
Mn.
Mn.
Concentration of the ions.
ions.
Ionic species. సరే గుడ్. ఇప్పుడు యానోడ్ దగ్గర the uh, the values at anode are constant. That means they are under standard conditions, but they are changing at cathode. So at cathode, what reaction takes place?
E cathode is equals to E naught cathode plus 0.0591 by N log concentration of M ions.
Are the ionic species?
Ionic pieces. Okay, ma'am.
Oxidation or reduction cathode
Reduction.
దగ్గర? Reduction.
Reduction.
Sign of cathode ఏంటి?
Sign of cathode minus,
Galvanic
ma'am.
cell. విను క్వశ్చన్ అది అవ్వలేదు.
Okay, okay, ma'am.
Galvanic or voltaic cell లో sign of cathode ఏంటి?
1 minute, ma'am. Positive,
Plus.
ma'am. Plus.
Cathode ఏ సైడ్ ఉంటుంది? రైట్ హ్యాండ్ సైడా లెఫ్ట్ హ్యాండ్ సైడా?
Cathode left hand side, ma'am.
సార్ నువ్వు మెల్లిగా చెప్పు, హడావిడి పడకు.
Okay, ma'am.
సెల్ నోటేషన్ రాసావా నిన్న?
Yes, ma'am.
సెల్ నోటేషన్ రాసినప్పుడు ఎట్ సైడ్ ప్లస్ సైన్ పెట్టావు.
Right hand side, ma'am.
సో క్యాథోడ్ ఏ సైడ్ ఉంది?
Right hand.
ఇంకా యానోడ్ ఏ సైడ్ ఉంది?
Left hand.
గుడ్. ఇన్ an electrolytic cell,
In electrode anode positive, ma'am. Cathode negative.
that's it. Good. Good.
Okay.
Okay. Roll number 73.
Yes, madam.
Good morning. Okay, Shashidhar, tell me, your mobile battery or your laptop battery is an electrolytic cell or a galvanic or voltaic cell?
Both, madam.
Both are. ఎప్పుడు ఎప్పుడు పోతుంది?
When cell phone battery is charging, it is electrolytic cell.
అమ్మా
When phone battery is charging, it acts like electrolytic cell, and discharging galvanic cell.
Good. That's it. That's the answer. So what type of cell it is? Reversible cell
Reversible
or
cell, madam.
Huh?
Reversible.
Reversible cell. Okay. So what is a reversible cell?
It acts like both cells.
అదే ఎప్పుడు అవుతుంది అది? చూడు అక్కడ
What,
ఇచ్చాను,
madam?
నోట్స్ లో ఇచ్చాను, ఒకసారి ఫటాఫటా చూడు. ఇట్స్ ఫర్ ఎవ్రీవన్.
ఎప్పుడు అవుతున్నాను?
ఎప్పుడు అవుతుంది అసలు? సెల్ ని రివర్సబుల్ ఇర్రివర్సిబుల్ గా ఎలా చెప్తావు నువ్వు?
రియాక్షన్ వల్ల, madam.
రియాక్షన్. గుడ్. దట్స్ ఆన్సర్. దట్స్ ఆన్సర్. వచ్చింది. ఇప్పుడు చెప్పు. When the cell reaction is reversible, then the cells are reversible cells. When
Yes,
the
madam.
cell reaction is irreversible,
Not reversible.
reversible.
Reaction is not reversible.
Not reversible, then the cells are irreversible cells. Antena?
Yes, madam.
Good, correct. Now tell me, how much EMF has to be supplied to make the battery reversible?
More than required, madam.
More than the EMF of the battery. Correct. Okay, good. Roll number 74.
Good morning, madam.
Yeah, good morning. Karthik, Chupama. Say, now, what it means by a cell?
Which have both anode and cathode.
Yes. Is your battery a cell?
Yes, madam.
Okay. How will you represent a battery?
With the positive and negative sign.
What I wrote on the board, is it right? The extreme right hand side. A thin long line and a thick short. Wrong?
No, madam, it's correct.
Correct?
Yes, madam.
Okay. So this is battery. So a cell is a combination of anode and cathode. Good. Now, how cells are constructed in a galvanic or voltaic cells?
By dipping same metal in its metal and solution.
Good. So, if you're dipping a metal in its own metal ion solution, that's how the electrodes are constructed. Ante, what the electrodes are called in a galvanic cell, Karthik? Sorry, ila adugta question. What are half cells?
Both when both oxidation and reduction happens.
Vinu, Karthik, oka nimisham. Half cell ante enti ani adiga. Anyone in the class? What are half cells?
Electrodes, ma'am. Electrodes.
Good, lovely. That's the answer. Electrode ante half cell ante. Sare. Anode is an electrode, and it in a galvanic cell it is called half cell. Why? Enduku? Oxidation sare ఎక్కడైనా అంతే ఎలక్ట్రోలైటిక్ సెల్ లో కూడా యానోడ్ దగ్గర ఆక్సిడేషన్, క్యాథోడ్ దగ్గర రిడక్షన్. థంబ్ రూల్ అదంతే. సరే, హాఫ్ సెల్ అని ఎందుకు అంటున్నావు? ఎలా కన్స్ట్రక్ట్ చేసావు? కార్తిక్, యూ టోల్డ్ ద ఆన్సర్. టెల్ మీ, రిపీట్. You're there, Karthik?
Yes, madam, there.
Cheppu, how half cells are constructed?
By dipping its
in its electrode అంటేనే ఫ్రెండ్ చెప్పింది కదా, ఎలక్ట్రోడ్ అంటేనే హాఫ్ సెల్ అని. ఇప్పుడు చెప్పు, how the electrodes are constructed? By dipping a metal rod in its own metal ion solution. Antena?
Yes, madam.
Okay. Now, how the construction of a galvanic cell is done? Cheppu, Karthik. తొందరగా చెప్పాలి, లేదా ఎన్ని ఎక్స్ట్రా క్లాసులు తీసుకున్నా నా సిలబస్ అవ్వదు. ఎలా కన్స్ట్రక్ట్ చేస్తావు చెప్పు. ఎట్ సైడ్ ఉంటుంది యానోడ్, ఎట్ సైడ్ క్యాథోడ్ ఉంటుంది.
Anode is left hand side. Cathode is right hand side.
How they are connected?
Salt bridge.
Internally. What salt bridge? What salt bridge does? Okay. External గా దేంతో కనెక్ట్ చేస్తారు? ఎక్స్టర్నల్ గా ఎలా కనెక్ట్ చేస్తారు? ఇదే. You have an idea, but this is what having idea is one aspect, and able to tell or represent or explain is another.
With wires, madam.
Enana?
Externally with wires. Connecting wires.
Internally with salt bridge. Using salt bridge. What does the wires do? What they facilitate? Through wires, what flow?
Flow of charges, madam. They allow flow of charges.
Electrons.
Electrons.
Okay. The direction of flow of electrons is from
anode to cathode.
Good. What does salt bridge does? Salt bridge
ions flow from it.
It maintains ionic equilibrium. How? How it maintains ionic equilibrium? Cheppu.
Not getting, madam. Don't.
Made of?
I'm not getting, madam. I don't know that.
Okay, no problem. Roll number 75, you know. 75 is present.
Good morning, ma'am.
Good morning. Yeah. Cheppu Nanna, neeku idea unda? Karthik?
By exchanging of
by exchanging of ions. Em chestundi? Salt bridge itself is made up of agar-agar medium in which a salt solution is incorporated, like ammonium chloride, ammonium sulfate, potassium chloride, potassium sulfate, like that. Okay. What it does, it will not allow accumulation of charges around the electrodes. Okay. So what will happen at anode? the negative charge comes out through the wire. Okay, that means electrons are released. When electrons are released, what ions concentration increase? M plus ion concentration increases in the solution. So what salt bridge does? It supplies the negative ions to the anode. At cathode, what is happening? Electrons are taken by the positively charged ions and they are forming the metal. So which ion excess is present? Negative ion excess is present at cathode. So what the salt bridge does? It supplies the positive ions to the solution and hence maintains the equilibrium. Okay. Okay. Now why I made like I was doing a small recapitulation to assess whether I am able to deliver the idea clearly to you all. Okay. Now, how the standard electrode potentials measured? Roll number 81.
Yes, ma'am.
Good morning.
Good morning, ma'am.
Arshit, cheppu nana.
Yes, ma'am.
What it means by a single electrode potential and what it means by standard electrode potential. Ucha?
Madam, single electrode potential means two half cells, madam. It is made up of two half cells.
Electrode potential half cells ante adi మొత్తం సెల్ రెండు హాఫ్ సెల్స్ కాంబినేషన్ ఏమో సెల్ అర్థమైందా నా క్వశ్చన్ ఏంటో విను సరిగ్గా సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్ అంటే ఏంటి what will happen if you dip a metal rod in its own metal ion solution? Sorry, in anyone in the class, define
The metal
what,
loses or gains
lose or gain of electrons.
the tendency of a metal or a non-metal to lose or gain of electrons is called as
single electrode potential.
when it is dipped in its own metal ion solution. Ade correct? Okay. What it means by standard single electrode potential? When the potential is measured at 25 degrees centigrade and 1 m concentration of the electrolyte, which I'll represent it as E naught. Now, how this E naught is measured for various metals and non-metals? Taking which electrode as reference electrode?
Hydrogen gas electrode.
Hydrogen gas electrode. Good, very good. Hydrogen gas electrode. It means what? That various types of electrodes are constructed for different utilities. Now, you know what is the construction of a hydrogen gas electrode? Okay. What is the construction of an hydrogen gas electrode? How it is made or built? What is its E naught
Platinum.
value?
Zero, ma'am. Zero.
Zero.
Zero na? Zero na?
Zero consider చేస్తారు మేడం.
Approximately zero, ma'am.
సరే అయితే
Reference కాబట్టి approximate zero.
అది కరెక్ట్ ఓకే సో దీనిని ఇంకో నేమ్ కింద చెప్తారు నార్మల్ హైడ్రోజన్ గ్యాస్ ఎలక్ట్రోడ్ ఆర్ షీ స్టాండర్డ్ హైడ్రోజన్ గ్యాస్ ఎలక్ట్రోడ్ కొందరు లైవ్ క్లాస్ అవుతున్నప్పుడు మామూలుగా కాలేజ్లో షీ అంటే నవ్వు సిగ్గుపడుతూ ఉంటారు ఏమిటో అంటే షీ అంటే ఏం లేదు స్టాండర్డ్ హైడ్రోజన్ గ్యాస్ ఎలక్ట్రోడ్ అని సరే I'll get back. So how it is constructed? I'll take a beaker. I'll pour 1 m or 1 n. It's the same. 1 m or 1 n HCl or H2SO4 solution. Okay. In that, I'll place a glass structure like this. Okay. Which has an inlet facility. Okay, and it is sealed from outside. Okay, from this inlet facilities I'll pass hydrogen gas at 1 atmosphere pressure and I'll for the electrical connectivity, I'll take a
Ma'am,
platinum.
please adjust camera, ma'am.
Is it okay?
Okay, ma'am.
Sare, I'll take a platinum black electrode. Ide platinum black electrode, which is sealed inside this glass structure. And it dips into the HCl or sulfuric acid solution, H plus ion solution. Yeah. Which is the electrode here is my question. Platinum electrode or hydrogen gas? Is which one
Hydrogen
is
gas.
hydrogen gas? Is he right?
Both.
Both ఒకటే చెప్పు. అయితే ప్లాటినం అవ్వాలి లేదా హైడ్రోజన్ గ్యాస్ అవ్వాలి, ఏది?
Hydrogen.
That's it. Good. Hydrogen gas ikkada electrode. You get the point. Okay, because it is with respect to the H plus ion concentration that is present in the solution. You understand? Are you able to see the contents clearly?
Yes, ma'am.
Okay. So H2 gas is the reduced form, correct? H plus is the oxidized form. This is oxidized state and this is the reduced state. Correct? Okay. So the electrode here is hydrogen gas. Just platinum is inert electrode. I already told with you all. What are inert electrodes? Electrodes which absolutely do not participate in the electrochemical reaction or the redox reaction are supposed to be inert electrodes. They stay undisturbed or unchanged during the electrochemical reaction or redox reaction that's happening. So hydrogen gas is the electrode here. Okay, so how can I classify electrodes now? One I was like telling you, metal rod dipped in its own metal ion solution is one type of electrode. Now in this electrode I have hydrogen gas, or the electrode is a gaseous form, okay, which is in equilibrium with the ionic solution. Okay, and hence accordingly now you say in that Nalgonda district, we'll get back to it when we are talking water chemistry. They'll say there is a lot of fluoride content in water initially, but now they have curtailed it. Okay, so what they do when they take the sample and do the analysis, straight away they dip one electrode into the water and know the concentration of fluoride ions. Okay, so how all these electrodes are constructed? Okay, accordingly, depending upon the construction of various electrodes, electrodes are classified into 5 major categories, which is the next heading to you all. Okay, put the date and write the heading. Okay, types of electrodes. Types of electrodes. Types of electrodes. And here I want to tell you one thing. Electrodes are classified into various types. Okay, but for our understanding, we'll study the electrodes classification depending upon on, don't write unless until I tell. I've classified electrodes depending on, first one is change in EMF, change in EMF, change in EMF or operating conditions. The second one is on construction. Okay. The first classification is depending upon the change in EMF or the operating conditions. Okay. Whether at a particular electrode, the EMF is changing continuously or it is remaining constant at a particular point. Okay. That will be the first classification. The other one will be depending upon the construction. Okay. The first one, you please do write this now. Types of electrodes. No, is the whole entire board visible to you all? Please do write. Okay. Now I'll further give the classification. Okay. First one, operating conditions or EMF change. It is okay. Sorry, the stand has fell down. So, under the operating conditions, are you able to say it clearly? Or change in EMF or EMF change, they are classified into reference electrodes. They are classified into reference electrodes or standard electrodes. They are classified into reference electrodes or standard electrodes. Otherwise, they are called. Is the board clear? Is the picture clear? Good morning. Hello? కనిపిస్తుందా?
Yes, ma'am.
కింద పడింది. Might be some problem అని. Okay. So first one would be reference electrodes or standard electrodes. The other ones are called working or indicator electrodes. Working or indicator electrodes. Okay. Reference electrodes are further classified into primary standard electrode, primary standard electrode, which is nothing but hydrogen gas electrode. standard hydrogen gas electrode, She, or normal hydrogen gas electrode. Whereas they're further classified into secondary standard electrodes. Secondary standard electrodes. Examples are calomel electrode,
Can you repeat again?
నేను చేస్తా చూడు కనిపిస్తుందా calomel electrode, silver chloride electrode, silver chloride electrode. Now I'll explain. Just keep a track. First you write this down, then you'll get the idea. Ferrous ferric electrode. Is the view better? Okay. Now let me explain here and just go ahead. Okay. I'll do it very quickly. By this time, it's clear what are electrodes. Electrodes are nothing but anode and cathode, and they are constructed in a galvanic or voltaic cells by taking a metal dipped in its own metal ion solution or a gas in equilibrium with the ionic solution. Okay, so first idea is that whenever I'm addressing the word electrode, it should be either a metal or a gas in equilibrium with the metal ion solution. Okay, so now there are many electrodes that are being used for different applications. I want to have an idea of what type of electrodes are there. Important ones. Okay, so there I've classified electrodes in different types. What is important to you here in this topic is, first one is change in EMF or operating conditions. The other one depends upon the construction. అంటే ఎలక్ట్రోడ్స్ ని అయితే మెటల్ రాడ్ కింద వేసుకోవచ్చు లేదా గ్యాస్ అనుకో, ఏదైనా సరే దాని మెటల్ అయాన్ సొల్యూషన్ లో ఒక ఈక్విలిబ్రియం లో ఎగ్జిస్ట్ అయ్యే దానిని ఆ కన్స్ట్రక్షన్ ని నువ్వు ఎలక్ట్రోడ్ అంటున్నావు. సరే, ఆ ఎలక్ట్రోడ్స్ ని చాలా డిఫరెంట్ కన్స్ట్రక్షన్స్ చేసాం మన యూటిలిటీ కోసం. సరే, మన క్లారిటీ కోసం దాన్ని క్లాసిఫికేషన్ కింద చేస్తున్నాం, ఎందుకంటే ఓన్లీ ఈజ్ ఆఫ్ లెర్నింగ్ కోసం. సరే, సో ఫస్ట్ క్లాసిఫికేషన్ ఏం చేశాను అంటే దానిని ఎలా రిఫర్ చేస్తున్నాను అని, అంటే ఏ కండిషన్స్ లో ఆ ఎలక్ట్రోడ్స్ ని యూస్ చేస్తున్నాను ఆర్ ఏమవుతుంది దాని ఈఎంఎఫ్ ఆ ఎలక్ట్రోడ్ ని యూస్ చేసినప్పుడు అనేది ఒక టైప్ ఆఫ్ క్లాసిఫికేషన్ కింద తీసుకున్నా. ఇంకోటి జస్ట్ కన్స్ట్రక్షన్, అంటే ఎలక్ట్రోడ్ ని ఎలా బిల్డ్ చేశారు అనే దాన్ని బట్టి నెక్స్ట్ క్లాసిఫికేషన్ చేశాను. సో నేను ఫస్ట్ క్లాసిఫికేషన్ గురించి డిస్కస్ చేస్తాను. ఓకే, సో under operating conditions or change in EMF, I've classified the electrodes into two types. One is the reference electrode or standard electrodes. The other electrodes are working or indicator electrodes. The definitions are very easy and simple. Ante enti? See, when the electrode is standard electrode, when the EMF is not changing and the temperature is 25 degrees centigrade and concentration of the electrolyte is 1 m. In such cases, any electrode is said to be a standard electrode. Okay, but it becomes a reference electrode when its EMF remains constant. Okay, and just now I have explained with you all the major important primary electrode that was used to find the single electrode potentials of various metals and non-metals is the hydrogen gas electrode, whose EMF was arbitrarily chosen as 0. So that electrode is called as primary standard electrode. So hydrogen gas electrode is the primary standard electrode whose EMF is arbitrarily taken as 0 and which was used to find the standard single electrode potentials of various metals and non-metals. So that's the classification. But handling primary this hydrogen gas electrode was not that very easy. Why? Because I have to pump in hydrogen gas, which should be very, very pure, devoid of any impurities, and the pressure has to be maintained at 1 m concentrate, 1 atmosphere pressure. Okay, if not, it becomes again non-standard. So using the gas was little more cumbersome under laboratory conditions. So what they have done is they could able to build other electrodes which could be used as reference electrodes. Also, all such electrodes which were built for getting the single electrode, standard single electrode potentials of other metals and non-metals, they have called them as secondary standard electrodes. Okay, examples are calomel electrode, silver chloride electrode. Now what makes them a reference electrode is what we will understand in just another 10 minutes time. But these are the electrodes which are constructed exclusively to make them a reference electrode. That means their EMF does not change during the operating conditions and hence are called as reference electrodes or standard electrodes. Okay. Otherwise, if the EMF keeps on changing or the concentration of the electrolyte is not 1 m, all such, that means the conditions are non-standard and non-equilibrium, the electrodes are called working electrodes or indicator electrodes, which are commonly used. Working or indicator electrodes are quinhydrone electrode and ferrospheric electrode. Sare, ఏమీ అర్థం కాలేదు కదా? Yes or no? You understood. I'm very happy. Now tell me. Roll number 91. Good morning.
Good morning, ma'am.
Chappu, em ardhamaindi? What it means by reference electrode? Nausheen? Yesterday also I asked you a question, Nausheen. Appa, daily నన్ను డైలీ క్వశ్చన్ అడుగుతున్నారు ఏంటి అని అనుకుంటున్నావా? అనుకో.
Ma'am, actually, I don't know Telugu.
Okay. Why are you thinking that I'm asking you questions daily?
No, ma'am, no.
No problem. Yeah, that should be the spirit. Whether we can answer or not, we should be addressed. That's most important. Is it? Now, Nausheen, tell me, what did you understand from my explanation? What it means by a standard electrode?
It is used at standard conditions.
It is used under standard conditions. Good. Okay. Does its EMF change during the operations?
No. Yes, sir.
Good. No, it does not change. Good. That's the answer. And these reference electrodes are further classified into how many types?
2 types.
2 types. What are they?
Primary and secondary.
Primary and secondary standard electrodes. Correct. Now, which is the primary standard electrode?
Hydrogen gas electrode is the primary.
In hydrogen gas electrode, what is the electrode made of? Got it, Naushin? You understood my question, what I'm asking you?
No.
How the electrode of hydrogen gas electrode built? Roll number 92.
Hydrogen, ma'am.
Hydrogen gas. Huh?
Yes,
Hydrogen gas at what should be the pressure?
1 atmosphere.
Good, 1 atmosphere pressure. And it is bubbled into solution. Which solution?
Ma'am?
This hydrogen gas maintained at 1 atmosphere pressure is passed into a solution of what concentration? Into which solution it is passed? Electrolyte ఏంటి? Metal rod dipped in its own metal ion solution kada?
Yes, ma'am. Platinum.
ప్లాటినం ఏంటి ఇక్కడ? ప్లాటినం కి రోల్ లేదు. హైడ్రోజన్ గ్యాస్ at 1 atmosphere కదా, దాన్ని దేంట్లోకి పాస్ చేస్తున్నాం?
Hydrogen acts as electrode, ma'am.
అవును. ఏ సొల్యూషన్ లో ఏముంది?
Electrolyte.
ఎలక్ట్రోలైట్ ఏంటి? ఏం ఎలక్ట్రోలైట్ తీసుకున్నా? ఇప్పుడేగా చెప్పాను. ఎలక్ట్రోలైట్ లో ఏమున్నాయి? ఎనీవన్ ఇన్ ద క్లాస్?
H plus
HCl.
HCl. 1m HCl.
Any acid తీసుకో, HCl, H2SO4 or any other acid which whose H plus ion concentration ఎంత ఉండాలి?
1m.
అంతే. Okay, so electrode is hydrogen gas, electrolyte is 1m concentration of H plus ions. Okay, what is the EMF of this electrode? 0. Okay,
0, ma'am.
so it is called primary standard electrode. Only hydrogen gas electrode is supposed to be primary standard electrode. సరేనా? బట్ హైడ్రోజన్ గ్యాస్ తీసుకుని మన ల్యాబ్ లో చేయడం అంటే ఇంపాసిబుల్. సో they have constructed few more electrodes who have some EMF value. That means their EMF value is not 0. They have some EMF value, but they can be used as reference electrodes. Such electrodes, they named them as secondary standard electrodes. Examples are calomel electrode, silver chloride electrode. Okay, this calomel electrode has EMF value, it is not 0. Only primary standard electrode, she is 0. Rest all have electrode potentials, but they are constructed for ease of using, and hence is the classification. Okay, secondary standard electrodes are secondary reference electrodes. Ante meaning enti? Their EMF does not change under operating conditions. Okay, and they have reversibility of ions. Ante they can be used both anode as cathode. The hydrogen gas electrode greatness enti? It can be used both as anode or cathode. Adi anode anuko అప్పుడు ఈఎంఎఫ్ సిరీస్ లో వేరే ఎలిమెంట్ క్యాథోడ్ అవుతుంది, వాటి సైన్ పాజిటివ్ ఉంటుంది. ఇది క్యాథోడ్ అనుకో, అప్పుడు ఈఎంఎఫ్ సిరీస్ లో ఎలిమెంట్స్ ఏమవుతాయి? నెగటివ్ -SRP వాల్యూస్ తో పైన ప్లేస్ చేశారు. ఓకే, సో అది. సో ఇక్కడ రిఫరెన్స్ ఎలక్ట్రోడ్స్ మీనింగ్ ఏంటి? క్యాలమెల్ ఎలక్ట్రోడ్ ఆర్ సిల్వర్ క్లోరైడ్ ఎలక్ట్రోడ్ అని చెప్పుకుంటే వాటి మీనింగ్ ఏంటి? ఎప్పుడు అవి రిఫరెన్స్ ఎలక్ట్రోడ్స్ అవుతాయి? ఈఎంఎఫ్ ఒకటి స్టాండర్డ్ కండిషన్స్ లో ఉన్నప్పుడు మారదు. దే కెన్ యాక్ట్ యాజ్ బోత్ యానోడ్ అండ్ క్యాథోడ్, రెండు కింద యాక్ట్ చేయగలం. అప్పుడే అవి ఎలక్ట్రోడ్స్ కింద చూస్ చేస్తారు అనమాట, రిఫరెన్స్ ఎలక్ట్రోడ్స్ కింద. ఓకే, ద నెక్స్ట్ క్లాస్ ఆఫ్ ఎలక్ట్రోడ్స్ ఇస్ వర్కింగ్ ఎలక్ట్రోడ్ ఆర్ ఇండికేటర్ ఎలక్ట్రోడ్. అంటే at these electrodes the EMF keep changing. Okay, they are also reversible in their ionic composition but can't be used as reference electrode. Okay, the electrodes at which the EMF keeps on changing is called as working electrode or indicator electrode. Okay, and they are usually used for non-standard conditions. Okay, so that's the first classification. Okay, next one. Right, two definitions and I'll just go to the next one. Okay, I think another 10 minutes time I have. Okay, listen. Right, reference electrode. Reference electrodes, the electrodes at which EMF remains constant during operating conditions. The electrodes at which EMF remains constant under operating conditions are called as reference electrodes. What are indicator electrodes? Indicator or working electrodes. Indicator or working electrodes.
Ma'am, can you please repeat that?
Reference electrodes. Okay, electrodes in which EMF does not change. Electrodes in which EMF does not change under operating conditions. అంటే అవి యూస్ చేస్తున్నప్పుడు నువ్వు ఆ ఎలక్ట్రోడ్ దగ్గర ఈఎంఎఫ్ మారదు. అంటే సపోజ్ నువ్వు హైడ్రోజన్ గ్యాస్ ఎలక్ట్రోడ్ తీసుకున్నావు, ఆ పక్కన ఏ ఎలక్ట్రోడ్ నువ్వు కనెక్ట్ చేసినా ఈ హైడ్రోజన్ గ్యాస్ ఎలక్ట్రోడ్ 0 వోల్టే ఉంది, అందుకే అది రిఫరెన్స్ ఎలక్ట్రోడ్. అంటే మీనింగ్ ఏంటి, ఎప్పుడు ఎలక్ట్రోడ్స్ ని రిఫరెన్స్ ఎలక్ట్రోడ్స్ అంటాం అంటే ఆ ఎలక్ట్రోడ్ వేరే ఎలక్ట్రోడ్ తో కంబైన్ చేసినప్పుడు అవి వాటి ఈఎంఎఫ్ మారదు. అంటే నువ్వు వేరే ఎలక్ట్రోడ్ ని కంబైన్ చేసినప్పుడు అది యానోడ్ అవ్వచ్చు, క్యాథోడ్ అవ్వచ్చు. ఈ రిఫరెన్స్ ఎలక్ట్రోడ్ తో ఏదేమైనా యానోడ్ అయినా క్యాథోడ్ అయినా దీని ఈఎంఎఫ్ మారకుండా స్టాండర్డ్ గా ఉండిపోతుంది. అలాంటి ఎలక్ట్రోడ్స్ ఏమంటాను, రిఫరెన్స్ ఎలక్ట్రోడ్స్ అంటాను. ఓకే, ఓకే, నౌ రైట్ ద నెక్స్ట్ డెఫినేషన్. Working or indicator electrodes. Working or indicator electrodes. Electrodes at which EMF keeps changing. Electrodes at which EMF keeps changing under operating conditions. Under operating conditions. Okay, so those electrodes are quinhydron electrode, ferrospheric electrode, which we will talk in detail down the lane. Okay, so I'll go to the next one, that is depending upon the construction. Electrodes are further classified into the first one. What is it? Are you able to see the board? Metal ion electrodes. Metal ion electrodes. metal ion electrodes, examples ఏంటి Zn plus 2 slash Zn, copper 2 plus slash copper, etc. are all metal ion electrodes. The second one is gas ion electrode. Gas ion electrode. Example. What's the example of gas ion electrode? Hello. What hydrogen. Is the example? ఒకటన్నా చెప్పండి.
Hydrogen.
Thank you so much. At least one has answered me. Is he correct? Hello. Don't get quickly bored. Keep your patience. We'll have to write it. There's no option but for. Example is hydrogen gas electrode. Like that, they can construct any electrode. Okay, gas electrode. See, these gas electrodes are having umpteen applications. See, actually, they are sometimes used as sensors for certain gases and all. I'll just talk to you about it if necessary, as per the syllabus down the line. Let me conclude this first. Third one is metal insoluble salt electrode. Metal insoluble salt electrode. Metal insoluble salt electrode. Examples are our calomel electrode. I shall give only one. Even silver chloride also is of the same category. Fourth one is redox electrodes. We'll be mostly talking about these two down now. Redox electrodes. Examples are twin hydron electrode. Fifth one is ion selective electrodes. I hope are able to see now clearly. Okay, what's the fifth one? Ion selective electrodes. Ion selective electrode. Example is glass electrode. Ion selective electrodes. I hope you're able to see the entire screen. Okay, that's the discussion. Next, right. Okay, what you have in your syllabus here is the description about calomel electrode and twin hydron electrode and how these two electrodes are used to find the concentration of H plus ions, that is pH of ionic solutions, is the next topic of discussion. Okay. Now, shall I explain the calomel electrode and conclude, or on Tuesday you want me to go ahead?
On Tuesday, you
We have
Yeah.
class again.
You have another class now.
Yes,
Huh?
ma'am. Max.
Maths class in that. Okay. So on Tuesday, I think on Monday you're jam packed. Correct? Monday you're jam packed, so I can't take any extra class. Okay. I'll just now take your attendance. See. Okay, 61. 61. 61. Answer your roll call.
61 present, ma'am.
62.
Present, ma'am.
63.
Present, ma'am.
64.
Present, ma'am.